So we can see here that we are using OmniParser and OmniTool, which I covered a day or two ago. However, what's going on now is it is actually all running locally on my machine and completely offline. So my big issue with this whole repository was basically before it required you to be hooked up to some sort of cloud instance for whichever LLM you were using, which personally I am not a huge fan of because it kind of limits you financially and kind of in things like that. But what we see right here is this actually working with Qwen2.5VL 7B, so the Qwen2.5 7 billion parameter vision model, and it is autonomously searching the web and doing some things like that. It is not perfect, but it is quote unquote free to use. And for today's video, we're basically just going to go over the changes made and how to actually go ahead and run this yourself. It was really quite simple to actually change this to work locally, thanks to the fact that the repository was already partially set up to actually work with Qwen, albeit through the cloud. So let's just hop right into it. So to actually implement these changes, I am going to basically go ahead and assume that if you're watching this, you have already installed OmniParser and OmniTool on your local system, which includes having set up the Windows 11 virtual machine and everything like that. Honestly, I did fork this repository and put the changes in there as well, but it really is only 2 scripts that need to be modified. And because I don't want to have to rebuild that Docker container, and because I honestly think that this would be a more efficient approach to changing your instance of this to work locally, we are basically just going to go ahead and actually directly change those 2 scripts from the original OmniParser installation that exists on our machine. So truthfully, this is quite simple. If you'll remember, when we actually went ahead and set this up, we created the Omni Conda environment. So the first thing we're going to do is basically just reactivate that Conda environment, which had all of the dependencies and everything to run this. And the next thing we're going to do, which is really the only additional things that need to be installed in this environment, is to go to the Qwen2.5-VL GitHub repository and scroll all the way down very far until we see deployment, which takes a while. And once we do that, we are going to basically want to install all of these dependencies into the Omni Conda environment that we created when we actually set this up for the first time. So we're just going to copy this, paste it right here, and press enter. Now, these are already cached and installed on my machine because I was obviously testing this to get it working. But if you are doing this for the first time, it will go ahead and just install these on your machine. And you may notice this is also installing vLLM, which is, of course, what we're going to actually be using to host this LLM that runs locally for us. So once that has been completed, the next thing we're going to do is something I'm actually going to do with the graphical file explorer, because it involves just downloading 2 scripts from the forked local OmniParser repository I made and placing them into this existing OmniParser repository. Again, I apologize if this is perhaps more technical and less easy to understand. I just kind of made this for folks who are more interested in like running this locally, and assumption is made that you followed along with this original OmniParser video I made so that some of this makes sense at a more accelerated pace, if you will. So from the file browser here, we are going to go into OmniParser, OmniTool, Gradio, and then the first script that we are going to modify is within the agent folder. And that is the vLLM agent.py script. So I am just going to go ahead and open this with Visual Studio Code, as we see right here. And yes, I will trust this workspace. Basically what this does is just kind of handles the things for like model selection and some things like that. It actually handles the prompt that gets passed to the models to actually go ahead and kind of steer them towards doing what we want them to do. So for this script, the modifications that were made, we can basically just go ahead and pull from my forked repository for this right here. And again, you could basically just clone this and start from scratch with my fork as well, but because I would have to rebuild the virtual machine with Windows 11 and things like that, I don't want to do that. So from the same location, which is the OmniParser, OmniTool, Gradio, and Agent directory, we are going to open this vLLM agent.py. And truth be told, what I'm going to do, which may be kind of bad practice, is just copy the raw file right here, delete the existing file that we opened in VS Code. So basically just select all the text and delete it, and then paste in the modified one. And we will see, just real quick to run through some of the changes that actually got this working. The actual prompt here I had to modify because Qwen seemed to be getting a little confused with it. There was also some kind of like thinking stuff here for if you wanted to use the R1 distilled version that they had as an option, and that seemed to be kind of tripping it up as well. The only real change we made is for Qwen right here, and we can see we pretty much kept everything. So for the API key, we're just going to put in like a random string of numbers and it will work fine. So we just kind of change this real quick to point to what we're going to actually have to download and put in the directory next, which is the script to kind of handle running Qwen locally with vLLM as well. And basically the only other thing that was changed here is this import right here, which is for a script that we are now going to go ahead and put in the code base or whatever you want to call it. So the next thing we're going to need to do is go into the LLM utils folder, and we will see that we only have these 4 Python scripts right here. However, if we go back into my GitHub fork for this and we go into the LLM utils folder here, we will see that there are 1, 2, 3, 4, 5 Python scripts. And the one we are going to add is this right here, this vLLM Qwen interleaved script. And I pulled a lot of this just kind of from this OpenAI client here, just as a base for kind of some of its functionality. And then on top of that, I also pulled some of it from the Qwen2.5 GitHub example, as they say, they do show using it with vLLM. So again, this was kind of more of a quick little modification I made, likely not perfect, but good enough to run and build off of, I suppose you could say. So it was the inference locally section here in the Qwen2.5 GitHub repo, where I kind of just pulled some of the references from here to actually have it working with vLLM. So as I take a deep breath, basically we are just now going to download this vLLM_Qwen_interleaved Python script. And once we have done that, we are basically going to drag it into the LLM utils folder from the existing OmniParser OmniTool repository that we made when we cloned it and ran it originally, as I did in my other video. So we just drag and drop that in right there, and then we are basically all set to actually go ahead and move on to getting this working locally. Now, I have been using this with Qwen2.5.7b vision, and again, these vision models, they may seem small parameter-wise, so like there's a 3 billion parameter variant and a 7 billion parameter variant, but architecturally, they take up a lot more space than if you were to, say, run like Llama 3.3b. That would take up far less VRAM than Qwen2.5VL 3b. So that's just something to note. I feel like I'm forgetting something here, but I am not. So that's good. So the only other thing that I kind of want to throw out there, and again, this video is probably a little more technical, but when I was actually running OmniParser and Qwen in vLLM at the same time, I was getting out of memory errors, and that was partially because I was letting vLLM use like a very large amount of video memory. So I set it to use maximum of 95% of the available VRAM, but unfortunately OmniParser being run at the same time was just causing out of memory errors because that uses a few gigabytes of video RAM as well. So what I did end up doing, and again, this is kind of like a more personally applicable fix because I have 2 graphics cards, but I basically ended up having OmniParser run on card 1 as we see right here. So forcing it to use this card, and then I had vLLM just run on card 0 here. So I kind of segregated which cards they were running on. It would, I think, be possible to just use the smaller Qwen 3B model and set vLLM to use like maybe 75% of VRAM, and that would likely get OmniParser working on one single 24 gig card or something like that. Again, I can't really say for sure what memory utilization will be requirement wise, as I'm only working with what I have here. So sorry, that was probably kind of convoluted, but the next thing we're going to do is basically just go ahead and actually run this. So, and again, if you watched my previous video, this will all make more sense, but basically the way to actually get this all running is kind of convoluted because you need to have like 3 different terminal windows open running 3 different things. So basically that's what I'm going to do right here, as we would have seen before. So the first thing I'm going to do is start OmniParser, and I can get to the correct directory that I need to be in to actually get this started right here. However, before I go ahead and run that, I need to force it to actually use card 1. So we are going to type export CUDA visible devices and then equals 1. So this will set it to basically just see graphics card number 1, which, don't get confused, graphics card number 1, like physically in the machine, is what is referred to as graphics card 0 here in NVTop, which is the program that I'm using to monitor these. I apologize if I get distracted. There is like a really horrible windstorm out there right now, so I am a little concerned about power loss. All right, so we did that, and then we can basically go ahead and start up the OmniParser server, which will be the first of the 3 things we need to do here. And assuming I did not screw up that export CUDA visible devices, once this starts, we should see graphics card utilization on card 1 start to spike, which is good. That's what we're seeing right here. So that is properly segregated for video RAM allocation purposes. The next thing we are going to do is create another terminal window, Conda activate. And again, I went over like all this, like starting it and things like that, far more in depth in my other video, in case this does seem somewhat confusing. The next thing we are going to do is go ahead and start the virtual machine with Windows 11. So we are going to navigate right there. And once we are in there, we are going to run this. There we go. So once we do that, it will start the virtual machine. So just make sure you're in OmniParser, OmniTool, OmniBox scripts before you run this. But again, I went over that more in my other video, so sorry if that was confusing. Then the final piece to the puzzle here, and what will actually kind of start using the local LLM that we're running this here, is to run the Gradio web interface. So we are going to first run this command. We need to make sure that our Conda environment is activated. It is. And once we have done that, we are basically going to run this command, which will start the Gradio application. And this will essentially go ahead and actually start vLLM and have it run Qwen2.5VL. And again, if you're running this for the first time, meaning you wouldn't have that model on your local machine, it will actually go ahead and download it before running it. So we do have that model already installed. And as we run that, we will start to see, we get a bunch of messages and things like that. But we will notice that video RAM usage on device 0 right here is going to spike to like 22 gigs. Also, I realized I didn't remember to actually export CUDA visible devices 0 here, but because it's not splitting across both cards, I probably don't need to do that. Now, I did try getting this working across 2 cards, but it wasn't playing nice, and I figured that's something to deal with for a different Bijan. So we can see that it will take a little bit of time here and get going. And once that is done, as we saw in the first time running this, which was like my other video, we will go ahead and run this, and we will see that we are connected to the virtual machine, and it does seem to have saved its state here, which is kind of interesting, and I don't want that. So if you actually want this to, like if you want to be able to interact with the virtual machine, you can click on this little icon right here, settings, and then uncheck view only, which means that you can actually interact inside the virtual machine. So I am just going to go ahead and close this. And once that's all set, we can basically go ahead and actually now try this running locally. So in order to do this, we need to change the drop down here for model into OmniParser plus Qwen2.5VL. So all of these names will have persisted from the original actually like OmniTool setup. And under API provider, it will auto set to dash scope, which was how you originally had to use Qwen, which was through the cloud, which we don't want. For API key, I'm just typing 111 because it's all local, so it doesn't matter. And then finally, we are ready to actually send a message to this and see it work locally. So I am going to have it open Google Chrome. Now, one of the limitations here that I've noticed is that even with kind of the like updated script in terms of the prompting for the model to return properly outputted JSON, it still doesn't work all the time. So this is more experimental, but I figured that it's much cheaper to experiment without having to pay for API access and things like that then, you know. So this is just kind of something, and we can see it will kind of go ahead and try to do things. I find that it doesn't work too well from the actual like desktop. If you wanted to do something, it seems to get a little confused. So what I did end up doing just to make sure the whole thing actually worked was I stopped it. I will delete this. And then I went ahead and I opened Google Chrome up for it, which I suppose could be some form of cheating. But again, I am just more interested in like getting this working locally as opposed to making it work perfectly. And again, this is the 7 billion parameter Qwen2.5VL. The only option that they had written was for the 72B model, which of course is far larger and far more performant, if you will. So I will just have it do something. All right, let's just have it do that just to kind of see it working, if you will. And we can see there that it basically is doing this in front of us. And sometimes I notice it doesn't necessarily like stop after the action is performed. So it will sometimes keep going until it trips itself up and things like that. And to be honest with you, one of the things that I was confused about, I've stopped it now, I'm taking over, is I was wondering, is Qwen actually seeing the images or is it just working based off of what OmniParser is doing? Because I was getting a little confused about its performance. So I actually did just end up asking something that it would only be able to answer if it was visually seeing what's on the screen as well. So describe the desktop background. And if we press send here, it will actually describe to us the kind of a blue abstract design with a flower-like pattern. So it is actually seeing, which is kind of cool. And again, this is less of like performance testing it. Okay, it opened Chrome. Hey, it did that itself. It normally was not able to do that, so that's good. Let's just try something funny, and then we will try the 3 billion parameter variant as well and see if we can get that plus OmniParser working on one single GPU. Yeah, so cause some havoc in this virtual machine. It probably won't do anything fun here, but you never know. Oh, it just, okay, so it just, just Google search that. Let's see what it does. It's something that I've still not gotten used to with these agentic frameworks and things like that, is just actually seeing them kind of control the computer without human interaction, like even the mouse moving or typing or things like that. So, all right, it is likely stuck here at this point, so I will go ahead and stop it, but it is... it is quite fun and cool. The next step really is to get it to work on the system, like in the base environment and not through a virtual machine, which is definitely possible. So now that we have gone ahead and done that, I am just going to Control-C right here, which will kind of end the Gradio web app process. And we are basically going to go ahead and change the script right here, which will allow us to instead run the 3 billion parameter variant of Qwen instead. So all we do is just change the commenting there, and we comment out the 7B. I delete this, which was a kind of embarrassing mistake to have made, and then we change right here to 3B. And then because I want to try to get this working with OmniParser on the same card, I'm going to drop memory utilization to 75% of VRAM, I suppose we could do. So now that we have done that, we should be using the 3 billion parameter version of Qwen, which truth be told, I don't know how well will work, but it will be cool to see, I suppose. And we are also going to want to end the OmniParser thing here because I had forcibly set that to use card 1. So we don't want to do that now. We want to see if it'll all work on the same card. So I basically just need to go ahead and redo those instructions for just OmniParser. Again, apologies if this video is kind of more fast-paced and technical than my normal ones, but I just figured it could be because I did the tutorial to kind of understand all this. You know what I mean. All right, so the next thing we are going to do is just go into OmniParser server right here, but the difference here is I have not exported CUDA visible devices, so this will start on the graphics card 0. So we'll see if they will both run in tandem on one single card. So we can see that this is now running on card 0, and we can go ahead and run the app.py for the Gradio app, and we will see if we run out of video memory. Again, I don't really know that I can speak to how much this is specifically going to use. Also, I don't know how well the 3 billion parameter Qwen will work, so that'll be interesting to see as well. And again, if you're running the model for the first time, it will actually go ahead and download the files from Hugging Face. All right, it does seem that they are both working together on one card. So let's just kind of go ahead and see what happens. We will, of course, have to once again change this and just feed in any API key. I've just been doing 111, but I would imagine anything will work. Close the browser window. And this is kind of really my first time seeing how well, if at all, the 3 billion parameter one will do. Okay, well, it did click. So that's good, and it's clicking again, and we're not out of memorying, so that's good. We can see the graphics card is being rather heavily utilized here, but it is running with OmniParser on one card as well, which is good because I didn't really like having to show this off just running on two cards because that's kind of a more obscure setup to be found in the hobbyist world. All right, and then we can see we get like some issues here with JSON, and that's kind of just one of the limitations of, I think, the model and the prompt is that it's a smaller model. So this is set to be working with the 72 billion parameter version of Qwen2.5VL, but we're trying it with the 3 billion parameter version. I will quickly just kind of go ahead and close the browser for it, and we'll just try a simple kind of quote-unquote cheating test again, if you will, which is just to have the browser open and then ask it to type something. So and again, sometimes I struggle in coming up with prompts to type because my mind goes to NSFW and then I'm like, wait, I can't type that in a YouTube video. So, and then we can see here. So it does seem to work pretty well within the browser. And again, for 3B, that's really not bad. And then it kind of just goes on its own and like starts doing random stuff, which can be kind of fun depending, but like it'll click random links and things like that. And I've noticed it doesn't seem to really stop very well, so it doesn't know when to stop, and then it kind of just generally keeps running until it gets a JSON error. So I suppose I will try one more thing. So let's see some images, baby. All right, and then let's see if it just knows to click images. That might have that might have confused it. All right, so we got an error there. Let's just close that. And then sometimes it can help to, I think, delete the history, although I don't know if that does that within the chat there or just visually. All right, so I think it's searched again. It's setting the browser as default. Hey, this is pretty good for 3B. Is it? It is fun watching. I'm like, it's fun watching them. In like 5 years, when the agents are super powerful, they're going to see me here like laughing at what the equivalent of like a newborn agent would be, and I'm going to be on the chopping block then, but oh well. All right, so that kind of did it. I did just want to kind of test this with OmniParser and the local LLM running on the same card, which did work, which is cool. If one could figure out how to get the model running on both GPUs, if you had two GPUs, it would be cool. But this was kind of just the little simple local fork that I was excited to do as soon as I saw all of this, because it's more fun to be able to do these things locally. It costs less money, although with the electricity cost, who really knows? But yeah, that's basically going to conclude it. Again, I apologize if this was perhaps a bit more fast-paced and technical than normal, but I did just kind of want to show this off. It is definitely replicatable at home, and hopefully someone who's far more skilled can kind of amend those prompts in the vLLM agent script, or where was it? Yeah, the vLLM agent script. Then you could definitely play with its output and try to kind of get rid of some of those JSON errors and things like that. But overall, this really was not very difficult to get working locally, which I'm very happy about. I had far more difficulty with Agentic 1, which was a different Microsoft kind of agentic thing. which was a bit different, I suppose, architecturally. But yeah, that is going to conclude it. I will post the relevant links in a pinned comment, one for the forked repository I made, and then for anything else I may have mentioned that I forgot. So yeah, I'm quite happy that this can run locally, and you can have fun with it depending on, your kind of point of view and humor, I suppose one could say. So thanks for watching. Any questions, please post them in the comments, and that'll wrap it up.